discussed we have discussed uh, the wall timing diagram, etc., in the previous lecture. So basically, what is wall timing diagram? What is port timing diagram? These things we have discussed in detail one by one. Uh, so, as per the requirement of the syllabus, we have covered almost all points, I think. So, once again, we will look for any points remaining, and then we will come back to. So this was the syllabus for the chapter 1, where we have discussed the introduction parts, where we discussed about what engine is, what is the constructional details of the engine, and what are the different parts going into the construction of an engine, one by one, their function, their construction, and so on. uh, then we discussed about the classification of IC engines. Uh, One by one, we went for how the classification is, or how the classification is being done. We discussed. So bas- basically, we classified on different bases like two-stroke engine, four-stroke engine, and so on. On the base of fuel, it was a petrol engine, diesel engine. On the base of cycle, auto cycle engine, diesel cycle engine, and so on. So like this, we discussed the different engines on the basis of different criteria, and we call that as a classification. Then we went on to discuss what is the auto cycle, what is a diesel cycle, how we are getting auto cycle, how we are getting a diesel cycle. We have compared this particular two cycles. Then we went on to discuss the wall timing diagram. So what a wall timing diagram is, how it is. We are getting this particular wall timing diagram. Uh, what is the difference between a wall timing diagram for a high speed engine and a at least low speed engine, we discussed. Then we went on to discuss the port timing diagram, and we discussed how the port timing diagram for a SI engine and CI engine differs. So uh, with this, this were the things what we have discussed in the previous lecture. And moving ahead, some more things related to this only we need to discuss. So what we are seeing on the screen is the wall timing diagram. So everybody knows about what a wall timing diagram is now. So basically, it is a graphical representation of um, the time that is opening and closing of the valves in a four-stroke engine. So along with the spark point, if it is a SI engine, and the fuel injection points, starting and ending points, if it is a CI engine. So that is what we have learned, and we said that this angles indicate the corresponds to the points at which the walls are being opened or closed early or after, that is before or after the dead centers. Uh, and we have also discussed why it is necessary to open the walls before or after the dead centers. What will happen if they open at dead centers, which we discussed in theoretical timing diagram. And in this, we discussed about the why we go for opening and closing the valves early or late, and how it affects the timing diagram. So theoretically, we said the suction, the compression, the expansion, and the exhaust were requiring the 90 degrees of the crank rotation, but actually it is not 90-degree, it is something different from that. So we discussed one by one how much it is. Okay, so one by one we discussed, and finally we had uh, a complete discussion of wall timing diagram. Now one thing which has to be considered over here is that, see, over here we start the cycle. We have discussed about starting of the cycle, that the inlet wall is opening and suction stop. Okay, so in the sequence of the operations, we say suction, compression, expansion, and exhaust. Okay, so these are the four operations which in a sequence we say when we talk about the timing diagram, wall timing diagram. Correct. And now you can see initially it started from here, then it went to top dead center, and it went to bottom dead center, then it went to on to again top dead center, then it came to bottom dead center, and then it went to top dead center, and moving ahead it ended over here. So we have here the wall opening and closing, and accordingly now you can see theoretically it is 360-degree twice, because we have two rotations. So once from here to coming back to here, it is 360-degree, and from here to here it is 360-degree, and here it is more than this, more than this. So 360 plus 360 plus some extra. So that is what is. So I hope I am audible. Any problem? Am I audible? Once again, somebody confirm me.
Yes, sir.
Yes.
Sir.
Okay. 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 So we have here this wall timing diagram where we said that we have the walls opening here. So the inlet wall is opened over here, and exhaust valve is closed over here. So this is a very important thing over here. See, that means if you take this particular angle as 20-degree, that is in this particular cycle, this when completed, already inlet wall has opened. So this particular region is called as wall overlap region. Okay, here walls are overlapping. What it means? It means that both the walls are remaining open simultaneously. Remember, theoretically it was not like that. Theoretically, when we discussed, we said here it is opening and here it is closing. So once it is closed over here, the other will open, and then next cycle start. This is theoretical, but actually how it is happening? Actually, inlet wall is opening here and exhaust wall is closing here. That means from this particular 20-degree, and if we're considering this as 10-degree, so around this 30 degrees, the inlet wall is open, exhaust wall is also open, because exhaust wall is going to close here and inlet wall has already opened here. Okay, so both the walls remaining open over this particular 30 degrees of crank rotation, and this is called as wall overlap period. Now, what is the consequence? What is the effect of how it affects the operation of an engine wall timing diagram? So you can see over here, both the walls are remaining open, and since both the walls are remaining open, what happens on one side? Since the inlet wall is open, the suction is being happening, and since exhaust valve is open, exhaust is also going on. That means there is a very high probability of, or rather it is happening so that some of the mixture coming in through the inlet is going to go out through the exhaust, because we know in a four-stroke engine both the inlet and the exhaust almost in the cylinder head, correct? So they are nearer to each other, comparatively nearer to each other, and therefore whatever is coming in through the inlet is probably going out through the exhaust directly. For how much period? During this particular wall overlap period. So this particular wall overlap period, we are going to have unburned mixture going out through the engine, even in case of a four-stroke engine. Even in case of a four-stroke engine. We have already discussed this thing in case of a two-stroke engine, where we said that since the inlet port, that is the transfer port, and the exhaust port is simultaneously remaining open, when the piston moves down towards bottom dead center, what is happening? The mixture was coming in through the transfer port and going out through the exhaust port. Similarly, in case of a four-stroke engine also, since both the walls, the inlet wall and exhaust wall, are remaining open simultaneously, which we call as wall overlap period. And since this is open, what happens is the mixture which is coming directly through the inlet is going to move out through the exhaust. Okay, and if this is higher, then it is going to have more losses. If it is lesser, it is better. But if then we have to again take into consideration that can we make it higher or more. So we have to, the requirement is that we have to keep it optimum. Okay, it has to be optimum. So what is the optimum? So we have, it means we have to keep it minimum. But again, if you keep it minimum, then here the problem will be coming that if you try to move the inlet wall opening towards the dead center, then the suction is going to be affected. Suction is going to be affected. If you are going to move the exhaust wall closing to the top dead center, then the exhaust will not be completely happening. That is, whatever the time is required for pushing out the exhaust, it will not be available. That means some exhaust is going to remain inside the combustion chamber. So that will affect the again the volumetric efficiency, because in the next cycle when we are supposed to make the combustion chamber completely empty and fill it with the fresh charge, but here it is not happening. So why? Because we are filling, we have already some amount of the exhaust gas remaining over there. So that means here we have to optimize. Here we have to optimize. We cannot make it very nearer, or we cannot take it more farther away. That is, if we take it nearer, then exhaust is going to be affected. If we take it more away, then wall overlap period is going to increase and the mixture is going to be lost. Fresh mixture is going to be lost. Similarly, the inlet wall opening, if it is very high, that is we are taking away, then it is better from suction point of view, but the overlap period is going to become higher and the mixture losses are going to be higher. But if the overlap period is that is opening is taken towards dead center, then what happens is your wall is not opening the early as per requirement, and therefore the suction will not be complete. That means the volumetric efficiency is going to be affected. So this is the effect of the wall overlap. So it is very important to understand what is wall overlap. So a question may be asked in the examination related to write a short note on wall overlap. So you should be in a position to tell what is a wall overlap. So you have to draw this particular wall timing diagram, and with the help of a wall timing diagram, you should be in a position to explain what you mean by wall timing diagram and how it is going to affect the operation of the engine. Okay, and what is it expected? So what is expected? It is optimum is expected. What is optimum? When we say when we can say it is optimum, neither it is minimum nor it is maximum. It is called as optimum. Okay. So because something is going to, negative thing is going to happen if you go for maximum. If you go for minimum, some negative thing is going to happen, and therefore we opt for, or we go for optimum. Okay. So optimum values of the wall here, wall opening has to be there. So we have to ensure that optimum values of closing, exhaust wall closing and inlet wall opening timing has to be maintained. So that is very important when we are discussing about the wall timing diagram. So this is about the wall timing diagram. So this was one important point which we comes after discussion of wall timing diagram. So we in the previous lectures we discussed what is a wall timing diagram. Okay, and a flow timing diagram. Now the next point was wall overlap period. Now here let me check out. So we have discussed about the cycles, where we said that we have 3 cycles: air standard cycle, fuel air cycle, and actual cycle. Air standard cycle was the ideal cycle. Fuel air cycle was the theoretical cycle, like Otto cycle or diesel cycle, and actual cycle is the cycle corresponding to whatever amount of work is being produced inside the combustion chamber of the engine, which is acting on the piston. Okay, so that is your actual cycle. And but still this is not what we get as output at the end of the crankshaft, because from here also there are some losses. Okay, some frictional losses and all happening, and finally whatever we get at the end will be lesser than this actual value. So the work output of an actual cycle. So I hope everybody has understood the actual cycle. And then with respect to that, we discussed some losses over here. So this particular losses, what we are talking of here. So corrected into different losses, and these are the losses what we have discussed over here. And the losses where here it is written time loss factor or time loss, which is 6%, heat loss, which is 12%, and exhaust blowdown loss, which is around 2%. Okay, and so this here 1 2 3 4 1 was your actual cycle. So this was here in between fuel air cycle, and your actual cycle was 1 A B C D 1. So that is your actual cycle. So I hope everybody understood. So this is the ideal one, like Carnot. This is the fuel air cycle, like Otto cycle, diesel cycle, etc. This is actual cycle what we have discussed now. So these were the things what we have discussed. Now you should be also in a position to compare the Otto cycle and diesel cycle. So keep in mind that you should be in a position, you are going to be in a position to compare the Otto cycle and diesel cycle what we have discussed earlier. So with this we say our chapter number 1 is over, and let us move on to our next chapter, that is uh, chapter number 2. So chapter number 2 is fuel systems in SI engines. So we have here fuel system. So basically here we mean to say we are going to discuss over here the fuel system in spark ignition engine. So basically we should also understand what is the fuel system first. Okay, so let us basically first discuss what is the syllabus, and then we'll go for actual description of the content of the uh, okay, so we have here, these are the points related to fuel system in SI engine. The weightage is for 6 hours. Uh, some problem in somebody? I hope no problem. Okay, so these are the points related to our syllabus. So here we will be discussing about the engine fuel requirements. Then we have the mixture requirements, simple carburetor, and additional systems. Misal, okay, additional system in modern carburetor, compensating devices, calculation of air fuel ratio, that is approximated and exact method. Then the calculation of main dimension of air fuel uh, here, main dimensions of air fuel system, supply system, and electronic petrol injection system, that is MPFI. So these things we are supposed to discuss one by one. So let us see basically what they are. So in the first point, engine fuel requirements, we will be discussing about what a fuel is, what the fuel should be like for a for it to be used in engine. So if you want to use a fuel in engine, what all properties it should have, what all the characteristics it should have, so that it can be suitable for engine. That is what we are saying about discussing about engine fuel requirements. So some requirements the fuel has to satisfy to make it suitable for application in an engine, and therefore we call it as a engine fuel requirements. Then the mixture requirements. Here we will be discussing about what are the requirements of a mixture, because in a SI engine when we talk of, you know that we are preparing the air fuel mixture outside the engine, and then we are supplying it to the engine. Okay, and when we supply it to the engine, basically we have it is in the form of a proper air fuel ratio. Okay, so proper air fuel ratio means what? So this comes under the mixture requirements. So some conditions, the mixture has to be prepared in a certain manner. It has to satisfy some requirements. Okay, it has to comply with the certain requirements of the engine, because we know that, see, when the engine is going straight on a moving on a straight road, no problem, we have some amount of fuel requirement. But when the same vehicle is going up a hill, it is climbing a hill, then the requirement of the fuel is going to be, power is going to be increased, and therefore the fuel requirement is going to be higher, and correspondingly the mixture requirement has to change. Correct. The same vehicle going down a hill, it is decelerating or going down a hill, then the power requirement is different, and corresponding to that power requirement, the fuel requirement is different. And therefore, as the conditions of the working of the engine changes, the mixture whatever you are going to supply has to change accordingly. So we call it as a quality of the mixture. Okay, and simultaneously we do have to change the quantity of the mixture also. So the quality and the quantity of the mixture need to be changed as the engine condition changes. Okay, and therefore we have some requirements to be that has to be discussed to understand what is the requirement of the mixture when we are supposed to use that particular for a vehicle moving up a hill. When we are going on a plain road, what is the requirement? So like this, as the condition changes, the mixture requirement changes, and these we are supposed to discuss over here in the second part. Then we have a simple carburetor. So basically, carburetor, we will be discussing what a carburetor is. Basically, it is a device where we prepare the mixture, okay, and we supply it to. So, basically, or theoretically, we have some device being designed, which will meet the requirement of the preparation of the mixture. Okay, and that particular carburetor, what we have is what we call as a simple carburetor. So a simple carburetor will be complying with the requirements. So some requirements will be there, and that particular requirements will be met by the simple carburetor. But as when we put it into application, engine application, then we know that the engine is going to come across different conditions. So when the vehicle is accelerating, when the vehicle is decelerating, when the vehicle is overtaking, when the vehicle is moving up a hill, when the vehicle is going down a hill, when the brakes are applied, and so on. So every time the conditions are changing, and according to the conditions, some extra things has to be added to the simple carburetor, and there that is where we discuss about additional system in a modern carburetor. Okay, so here we will be discussing about some additional things what are required to be added in a simple carburetor in order to make it a complete carburetor. So here we were discussing about a simple carburetor, and when we add this particular additional system, this is called as a complete carburetor. Then here we have some some what we call as some disadvantages in a simple carburetor. Okay, some disadvantages in a simple carburetor. And to overcome these particular disadvantages, we need to discuss about some compensating devices. So while discussing the point compensating devices, we will come to know what exactly this compensating devices are. But presently, let us consider that this is the systems added in a simple carburetor, which helps in overcoming some disadvantages of the simple carburetor. Okay, and therefore they are called as a compensating devices. So they are going to compensate something. So some ill effects are there, some disadvantages are there, that is going to arise in the working of a simple carburetor. That is going to be taken care by providing compensating devices. So that we have here. Then the calculation of air fuel ratio. So this comes under the derivation part. So here we have the calculation of the air fuel ratio with in an exact method and approximate methods. So we have two methods over here for calculation of air fuel ratio. So the two methods are arising due to the fact that you know that air is compressible. Air is compressible. If you consider air as a compressible, then the conditions what we have to apply for the derivation are different. And if we consider that air is not compressible, uh, then we have to apply different conditions, and accordingly we have two methods, and that is where we have exact and approximate method. So one of it is exact and one is approximate, and accordingly we have this particular two systems, derivations coming into picture, and correspondingly some numericals also. And we do have some numericals related to calculation of the main dimensions of air fuel supply system. So here we will be trying to calculate the main dimensions of the air fuel system. Okay. So here the main dimensions of the carburetor are going to be designed for. So for example, we will say the engine is like this. It is this many cylinder, it is this much power we have to produce, it is working on so and so speed, and it has to produce so much power, and then what will be the air fuel ratio required. Okay, such calculation we'll be doing over here, or we will be seeing the otherwise. If the air fuel ratio required is this much and the conditions are this much, then what should be the dimension of the jet which is injecting the fuel into the carburetor? So like this, some main dimensions we'll be calculating with respect to carburetor will be designed for. And finally, we will be discussing about the MPFI system, that is multi-point fuel injection system, which is the recent trend in petrol engine. That is, we are nowadays using in many vehicles MPFI type of engines. That is, these vehicles are going to use injectors instead of carburetor. Okay, and this particular injection type of petrol injection type of systems which we call as MPFI, or multi-point fuel injection system, or electronic petrol injection system. Okay, we will be discussing about this particular. So this is a recent trend in the SI fuel injection system, or fuel induction system, whatever we call it as. So that was the things what we are supposed to discuss in the chapter number 2. That is unit number 2. Before going to start, before starting the contents related to chapter number 2, may I ask, because in the last lecture when I discussed about the doubts, there were so many students has been left earlier, and when I asked the doubt to avoid the questions, many students started leaving. So now I will ask whether anybody having any doubt related to chapter number 1, they can ask for now. Anybody? So I will give you 2 minutes. So anybody having doubts, you can ask with respect to the chapter number 1, so that we can directly start now chapter number 2. And moreover, I have given assignment questions. Okay, 5 questions I have given in the assignment. So those either were absent or has left early and are not knowing related to this particular questions, get it from your friends. Okay, what the questions are. We have discussed this particular questions in the classes, and I'll ask why discuss what is supposed to be written in the question. So now that no questions are coming related to chapter number 1, I presume that everybody has understood everything. Okay. So see, once I say everybody has understood everything, further when you come to me for a doubt, then I will ask you to. I will not ask directly. Tell you the thing. I will initially tell you to go and read this thing and then come in, and I will be clearing your doubt through question and answers. Okay, uh, remember this. So because uh, there are some students who will come at the end and say, "Sir, I have not understood chapter number one." Such students will not be entertained because mm, it is very important that you attend. And when we are asking you to whether you are having doubts, you should be in a position to ask the doubts. So uh, since you are not asking the doubts, I presume that everybody has understood everything from the chapter number one. It does not mean that again that you are not supposed to ask your doubt. Remember, okay. So whenever you are having the doubts, you are supposed to come up with the doubt. And moreover, I am always saying that engineers should have questions in their mind, without which they are not fit to become a proper good engineer. So always ensure that any doubt you are having, please ask. Okay, so that it can be clear. So no problem. We'll move ahead. First point is desirable properties of a good IC engine fuel. So we know that we have a fuel required for engine. Now, where this idea come from regarding the engine? Basically, even when we discussed the chapter number one, we said that initially the research related to engines started by uh, assuming that if something can be burned in a lamp, then it can be burned in engine also. Why not? It cannot be burned. That means if certain oil or certain liquid can be used, or a certain fluid can be used as a fuel in a lamp, and it is burning over there, then why not it cannot be used as a fuel in the engine? So anything which can be burned in a lamp, it should be able to burn in a engine also. So that was the starting thinking. Okay, thinking where it started that we can use oils, and generally it started with the vegetable oil research. So initially it was all the vegetable oils being researched, uh, but slowly we discovered at that time when we started the initial research related to fuels of ICE engine, we didn't have the petroleum fuels. Later on, the petroleum fuels were developed, and the petroleum lobby becomes so powerful, and moreover, the technology related to petroleum fuels were developed. So this particular lobby encouraged the research related to petroleum fuels, and they directly or indirectly discouraged the research related to vegetable oils. And therefore, what happened was later in the later stage, all the research related to engine fuels was done in petroleum fuels, and researchers dropped the idea of researching the vegetable oils. So if you go for literature review, you can see that for many years there was no much considerable research related to vegetable oil. Uh, and more, almost we can say more than 90 or 95% of the research related to engine fuels were related to only petroleum fuels. Okay, and the technology developed and flourished and so on. It went on slowly and slowly ahead. But the stage came when generally two problems arose. One is related to the pollution, so the atmospheric pollution. So nowadays we are talking of global warming and so many things. Okay, sea level water rising, then um, uh, global warming where the heat is going to increase inside the atmosphere. Okay, so many things we are talking of, and we say the pollution is responsible for that. Okay, and where the pollution is coming from? Pollution is coming from burning the fuels. So naturally, who is the most important contributor? Obviously, one of the most important contributor is the fuel used for generation of the power, and second is the automobile industry. And we are here concerned with engines, so we are more concerned with automobile industry. Okay, that means then, since the pollution becomes an issue, then people started thinking of whether there are some options where we can uh, check out whether they are of making less pollution. So this was one reason why again research started with uh, vegetable oils. Uh, Now, again, the concept of the fuels, you might have studied this particular concept of fuels in case of your basic mechanical engineering, like conventional fuels and alternative fuels or renewable fuels. Okay, so conventional fuels are those which we generally use, which come the petroleum fuels comes under this particular category because that is generally what we are using nowadays. And uh, we have the alternative fuels which we are having it reproducible. That is when we are taking something from the atmosphere, and when we are burning it again, you letting it to atmosphere, then we don't consider it as pollution. So that is the concept behind that. Okay, and accordingly we have conventional and alternative or renewable fuels. Renewable fuels. So now when we are talking of this particular fuels, uh, for burning it to be in the engine, may it be any type of engine, it requires some properties. And what are these properties which it need to possess, which has to be there to ensure that they are going to be used for engines? Okay, so the first and very important is the high energy density. So here it is listed over here. And the first is high energy density. What is this high energy density? Means what it means is that by burning a small amount of fuel, we should be able to get more amount of energy. So we call it as energy density. So the density of the energy is more. Means by burning small amount of fuel, we are able to get more amount of energy. Uh, to give an example, uh, uh, when I asked initially the introduction of the students, many students said that they are from rural background, and they are either son of farmers or so. Okay, they are somewhere related to agriculture. So I will give an example of related to agriculture there. So we have something called as in Marathi we call it as we have chipad, that is the waste material remaining after reaping the crops. Okay, the stem of that particular plants we call it as chipad, and that is generally dry wood. Okay, and if you take a wooden log, okay, so this particular if you compare which one will give you more energy, obviously the wooden log, because if you try to burn the wooden log, that means if you take a wooden log, you cut a branch of a tree, you will get a wooden log. But on the contrary, this particular waste, dry waste of this particular vegetable, sorry, this particular crops, let it be maize or bajra or whatever you have, okay, bajri or bajra, whatever you call it as. uh, um, so this, whatever that stem of this particular crop, so if you burn that, basically you know that it burns very easily and it cannot produce more energy. So here we can say the energy density of this particular maize or bajra vegetable waste is lesser than the wooden log. So this example was just to make you understand related to what is energy density. Okay, so that is about energy density, and what we want, higher energy density. So it means by burning small amount, we should be in a position to produce more energy. Then ignition or combustion quality. So that is the second thing required. That is, we want the ignition quality to be good. That is, the ignition quality of the fuel should be better. That means it should burn as per the requirement of the engine combustion process. Why we are discussing about this? Because we know that on the basis of combustion we have SI and CI mode of combustion. Correct. So in SI we are burning the fuel in a different manner. In CI we are burning the fuel in a different manner. So some fuels which will be more suitable for SI and some fuel will be more suitable for CI mode. Right. So that is where we are saying of the ignition or combustion quality. So the quality of the combustion or ignition, it should be suitable for the engine whatever we are going to propose it for or use it for. Okay, so that becomes another important quality which decides which type of engine we have to use. Correct. So that is how we have a petrol in a different quality and we have a diesel for a different quality. And we know that petrol is more suitable for SI type of operation and diesel is more suitable for CI type of operation. So that is where this particular ignition or combustion quality is going to change. What it means is that the way the combustion is happening, the manner the combustion is happening for a petrol and for a diesel is different. Okay, and that is how it becomes suitable for either for SI or CI. Okay, so that is about the ignition or combustion cost. Then we have the volatility or viscosity. Now here we know that here we are talking of volatility. What is this volatility? Volatility means the tendency to evaporate, because we know that fuel is not burning in the combustion chamber in the form of a liquid. It is burning in the form of a vapor mixture. Vapor mixture. Air, fuel, vapor mixture. That means initially we have to convert the liquid fuel into vapor. That means it has to be vaporized. So the process of vaporization is what indicated by the term volatility. So its volatility characteristics, how it is going to be volatile. For example, if I put some small amount of petrol in one jar and nearby same amount of diesel in another jar, we know that after some time the quantity of the petrol is going to in the jar is going to become less and the diesel will almost remain the same. It will also evaporate, but the amount of evaporation is going to be less. So what it indicates, it is an indication of volatility. Okay, volatility. So the higher the volatility or lesser the volatility. So how easily the fuel vapor is able to convert into vapor is indicated by what you call as volatility. Then we have the term viscosity. What is this viscosity? Viscosity is a tendency to flow. So or resistance to flow. Okay, resistance to flow. So basically we know that we have cooking oil and we have also ghee used in our kitchen. So the cooking oil, whatever generally we use, may it be soybean oil or coconut oil or sunflower oil, whatever it is. And when we compare the tendency resistance to flow of this particular cooking oil to the resistance to flow to of ghee, that is ghee made from the cow milk or made be buffalo milk, doesn't matter. So we know that it is more viscous. So that is the viscosity. Okay. So the resistance of to flow is more in case of a ghee than in case of a cooking oil. Okay. So that is what we call as a viscosity. Okay. So the volatility, then the viscosity, then the starting characteristics. So it is again one of the important characteristics because that is going to again decide how easily the engine is going to start and accordingly which type of engine it has to be used and how the engine has to be started or what provision has to be made for starting the engine. So that will decide. So how easily we can start the engine. So start the combustion basically. So starting means basically it is related to starting the combustion or starting the ignition, we call it as. So the ignition or the burning characteristics of the fuel is what you call as the starting characteristics. So how easily we can start the burning of that particular fuel. So for example, I will go back to the same example initially what I have discussed about the wooden log and the waste of the bajra. Okay, so we know that the bajra waste is very easy to burn, while the wooden log will not burn easily start the burning. Correct. So that is where we call the starting characteristics. Okay. So here we are talking of the fuel which can be used of engine. So which can be easily starts its burning and or it is difficult to start its burning. Okay. So if you put it in this particular example, the bajra waste is very easily able to start burning. correct? If you just hold it on the lamp for half a minute, it will start burning on its own. But on the contrary, if you hold the wooden log on the lamp for 1 minute or 2 minutes or 3 minutes, it will not start easily burning. Correct. So that means it is difficult to start burning, and the bajra base is easily to start the burning. So that is where we call it as the starting characteristics. Uh, then we have the corrosion and the wear. So here we are talking of the corrosion, the corrosive properties of the fuel. So it should not happen that we have a fuel system and after 1 or 2 months or 6 months, all the internal parts of the fuel system is being corroded due to the fuel itself. It should not happen. So the compatibility of the fuel with the parts, fuel system parts, okay, depends on what is the corrosive nature of the fuel. If it is highly corrosive, then we have to use the special materials and all. Then the fuel system will become complicated. It will become costly and so on. Okay. Similarly, the wear. Okay. Then we have the handling ease and storage. Handling is see when we want to handle means we are carrying from one place to another. It should be easy to handle. So if you take the example of again the cooking oil and the ghee, then we know that cooking oil is easy to carry than the ghee because the viscosity of the ghee is more, so it becomes difficult to transfer from one container to another or uh, uh, from one place to another, etc. etc. Okay, so that becomes the handling ease. So ease with which we can handle the fuel is the handling ease, and storing. Also, it should be easy to store. So when we talk about storing, then easy to store means the safety comes into picture. Moreover, how we can store it, where we can store it. Okay, what are the containers used for storage, and so on. Because suppose we have a water tank on the building, can we store the petrol in that particular tank? Obviously no, because it is highly volatile, and if you put the petrol in that, we know that it is going to slowly decrease the volume day by day, and slowly it vanishes. Okay, so that becomes an issue while storing. So we want a airtight container, and we have a provision for breathing, etc., etc. All those things has to be there. So what is the storing provision required for that particular fuel? That also is going to be an important parameter for deciding the fuel. Then the thermal stability. So this is again an important parameter when we compare the fuel, basically the petroleum fuel with the vegetable oil. So we know that anything from the vegetable source is undergoing biological decay. Biological decay. That means if we keep the vegetable oil, suppose for 1 year, what will happen? The smell of the vegetable oil changes. Correct? Any vegetable or vegetable origin thing after some time will undergo biological decay, and accordingly its characteristic change. Its taste changes, its smell changes, and so on. And since if you are producing some oil which is having some vegetable oil base, then obviously it is also becoming biologically unstable. Correct? So, or you can call it as a thermal also. That means when the temperature changes, certain oil changes characteristics. Okay, so under cold condition it is behaving in a different manner, and in a hot condition it is a different manner. For example, if you again take a biological, you know that if you want to store the vegetables, you store in the fridge because the condition over there is cold. At hot temperature it is decaying very easily, so it is thermally unstable. So here we are talking about thermal stability, that is irrespective of whatever the temperature fluctuations are there, changes are going to be there. It should not change its characteristics, otherwise it becomes a undesirable property for the fuel. Similarly, we have the easy and economic availability. So whatever fuel you are going to choose it for an engine, it should be easily available everywhere. It should not happen that I have an engine over here and the fuel is available in America. Then how I can run the engine? Correct. So then I have to import it, and whenever I import it, then that becomes an issue. So obviously, presently we are more relying on the imported fuel only, but that should not be the case. It should be ease availability. For example, suppose we are talking of the biodiesels. So biodiesel, suppose I am producing the biodiesel from the coconut oil. Then uh, then this particular biodiesel will be easily available in the coastal region, like Konkan or in the Kerala or the coastal areas of Karnataka or Andhra, whatever states we have. But what about the interior, like UP or Bihar or Madhya Pradesh, where generally the coconut agriculture is not there to higher extent. So there we cannot get this particular raw material of coconut oil. So we'll get this particular raw material in the coastal areas, because we know that in the coastal areas we have much of the coconut cultivation. So there the biodiesel produced from the coconut oil will be suitable, but in the other regions it will not be suitable. Or you take a Himalayan region where there will be availability of the coconut oil, no, then it becomes an issue. So the ease of availability, and it should be more economical also. It should not happen that it is very much costly. So if you have the, for example, same example of a take, if you take the example of coconut oil converted into biodiesel, and you are using it in the Himalayan region, so obviously we have to get the coconut oil from the coastal areas, then we have to convert into oil, then we have to transport it to the Himalayan region. Obviously, the cost will go into increase. On the contrary, if you are talking of the availability of this particular oils in the coastal areas, it will be huge. So the cost will be less. So that is going to make an issue. So the economically feasible, that is the price should be less, and the ease of availability. So everywhere it should be available. So that is again one of the requirement of fuel to be used in engines. Then low deposit forming tendencies. What is this low deposit forming tendencies? So it should not form any deposits. For example, we know that mm, if you know a lamp, you have some deposits. We call it as kajali, correct? So some deposits are over there, and these deposits are coming due to whatever is being burned. When the oil is being burned, something is being produced. It is in the form of carbon, and that is being deposited somewhere. So like this, when some oils are being burned, they are unable to convert all the constituents of the oil into energy or in the gaseous form, gaseous products, and they are also producing along with the gaseous products some solid or liquid constituents which are getting deposited. Okay, and these are called as deposits. Okay, so the whatever the fuel what we are going to use, it should have lesser deposits. Why? Because take the example of an engine. So if the carbon deposits are more, we know that uh, is suppose we take a spark plug. We know that in the spark plug, if the carbon deposits are there, then it starts giving starting problem. Correct. Then we have to take it to the mechanic, and then he will clean it. So frequently maintenance will be required. So that becomes the issue. So the deposit forming tendency of the oil is going to again important property which has to be taken into consideration before it is going to be used in engine. Then good fire safety. So we know that the fuel, whatever is going to be used, is going to be burned because it is inflammable. That is why it is considered as a fuel. But from the point of view of safety, it is dangerous. So that is where we have, see, we have in the petrol pumps and all, we are instructed not to use the mobiles, etc., because the electromagnetic waves coming out of the mobile, etc., they will result in catching a fire. Okay, so that means it is dangerous over there. So the fire safety again is an issue. So that properties also has to be considered. If something is very easily catching fire, for example, if I take a hydrogen, that becomes in hydrogen, it is considered to be a very disadvantageous because it can catch fire very easily. So that becomes a very important property. which has to be taken into consideration when we select a fuel. Because one of the disadvantage of hydrogen fuel is considered that it is very easily catching fire, and therefore fire safety is a very important consideration when we select the fuel for fuel like hydrogen for engines. Low toxicity. That means here we are talking of pollution in terms of pollution. That is, whatever the products, the combustion products are being produced, when we burn that particular fuel, it should not be basically polluting. So the combustion product should not be considered, rather, it should not be pollutants. Whatever we consider as pollutants, they should not be produced. Okay, so those gases should be produced which we don't consider as pollutants. Okay, so in that terms, it has low toxicity. Or in other words, also, for example, if I'm using a leaded fuel, then the lead, when come out of this particular exhaust, along with the exhaust gases, this is going to deposit on the lungs of the human beings, and it is very dangerous for, preferably for small children. Okay, so it is the toxic in nature. Toxic in nature. Similarly, we have carbon monoxide. If carbon monoxide is more, it is a very poisonous gas. So it is toxic. So such things has to be taken into consideration. Uh, these were some of the characteristics or properties which are considered to be desirable when we consider a fuel, when we choose a fuel for an engine. Okay, so once again, high energy density, energy with a less amount of fuel, we should be able to produce more energy. The combustion should be easy and suitable for the engine, whatever we are going to use. It should be easily able to convert into vapor, and therefore it can burn easily. It should be able to, that is viscosity, that is we can make it flow from one region to another or one container to another if the viscosity is uh, lesser. If the viscosity is more, it will be difficult to transfer from one container to another. Starting characteristics, burning, initiation of the burning has to be easy, because we want to burn it in a very short amount of time. Then smoking and odor. Here the smoke means, when we burn fuel, we know that this smoke is going to produce. We have the smoke coming from chula. Okay, so this particular smoke is there. So the smoking tendency of the fuel should be lesser. Odor means smell. So the smell should not be there. So there are so many pungent smells coming. For example, the odor becomes a very important parameter when we discuss about the biodiesels, because we know that when we use a cooking oil in the kitchen, we have certain type of smell. Okay, we call it as a odor. So if you use biodiesels are those diesel fuels which are produced from biological sources. So if you use these biodiesels, then when the vehicle is traveling in the on the road, we will have a feeling like we are in the kitchen, because the exhaust will smell like the whatever the smell what we have in the kitchen. Okay, so that becomes a order. So the order is again issue. So some like some type of orders, some don't like some type of order. So order is again a issue. Corrosion and wear. The corrosive tendency, the fuel should not be highly corrosive, and it should not help in wearing out the different components used in the fuel system. Handling, it should be easily handleable. Storing, it should be easily stored and easily transferred from one to another container, or one place to another place, etc. Fuel should be thermally stable. That change in the temperature, it should not change its properties. It should be easily available everywhere. It should be cheaper in price. It should not have any deposit forming tendencies, and it should be safe to use from the fire point of view, and it should not produce any toxic gases. So these are the desirable qualities for a fuel to be used in engine. Uh, I hope this everybody has understood the desirable properties of the fuel. So the first point what we have discussed is the desirable properties of the fuel. Now moving ahead, now we have fuel system for a petrol engine. Now we are not here discussing about the fuel qualities of SI engine fuels and CI engine fuels, because we have a separate chapter of the fuels where we again we will be discussing about the properties of the SI engine fuel and properties of the CI engine fuel. Okay. We consider this particular properties, whatever we have discussed till now, are generally common for all the fuels. Okay. Some values here and there different. For example, the volatility of the petrol is higher than the volatility of the diesel. Depending on the volatility of the petrol, we have a different types of fuel system in case of SI engine, and we have a different type of fuel system in case of CI engine. So such things we will be again discussing as and when required. Okay. So moving ahead, we have a special type of fuel system required for a petrol engine. Now, the most important property of the petrol fuel is its volatility. Volatility. What is this volatility? Its tendency to vaporize. That is getting converted from liquid to gas. Is a vaporization. So, keeping this in mind, we'll move ahead to this particular figure, what has been shown. So these are the important components of a fuel system for a petrol engine. We have here a fuel storage tank. We have here fuel pump. We have a fuel filter. We have a carburetor, and the fuel is going to engine cylinder. So this particular block diagram shows the flow of the fuel in the system. So as indicated over here, fuel storage tank. So we have a fuel tank in almost all vehicle. Everybody knows there is a tank. And why we have a tank over there? In order to store the fuel. So we are storing the fuel in this particular tank, and we call it as a fuel tank. Now, what has to be taken into consideration when we design a fuel tank? So basically, it should have a sufficient capacity, obviously. Then it should be, the tank should be such that under all conditions it should be able to supply the fuel. Okay, so under all conditions means whether it is rainy season, whether it is summer, whether it is winter, in any condition it should be in a condition to supply the fuel. So it should not happen that due to winter now the fuel tank is unable to supply the fuel, or due to summer it is unable to supply the fuel. Something like that, it should not happen. So that is what we call up. Okay, so that is again important. So and moreover, under all the working conditions of the vehicle, for example, it should not happen that since the vehicle is going down a hill, now the tank is unable to supply the fuel, and so, or when the vehicle is going up a hill, the tank is unable to supply the fuel. It should not happen. So the tank design should be such that in all the required conditions of the working conditions of the engine, the fuel need to be supplied as per requirement to the engine. Okay, so that has to be taken into consideration while designing a fuel tank. Then we require a pump. Why we require a pump over here? Because we know that the fuel has to be supplied. So obviously the location of the tank will be at a lower side and the engine will be at the upper side, correct? So if it is reverse, what is going to happen? So if the tank is at a higher level and the engine is at a lower level, always the fuel will be going to the engine, which is not the requirement. When the engine is not in a working condition, we don't require any fuel to flow into it. Therefore, what we do is we put the tank at a lower location, okay, and compared to that, the location of the engine will be at a higher. Therefore, if you want to supply the fuel, you will be requiring some element which is going to supply the fuel, which is going to suck from the tank and supply it to the engine as per the requirement. Okay, and that element is what you call as a pump over here. So the fuel pump supplies the fuel, sucks the fuel from the container or the storage tank and supplies to the fuel supply system, which is going to supply the fuel to the engine. Then this particular fuel need to be filtered. Now, why it need to be filtered? Because we know that we have already discussed this particular filter, fuel filter, when we discussed the components of the engine, where we said that this particular filter has to remove all the sediments or all the unwanted particles in the fuel. Okay, solid particles in the fuel or dust, whatever it has. So these particular unwanted particles which are there in the fuel, coming along with the fuel, and which are not supposed to go to the combustion chamber, uh, has to be removed. Why? Because if they are allowed to go into the combustion chamber, they are going to work as abrasives. That is, they are going to add in the wear and tear of the parts of the engine, and therefore we should not allow them to go inside. That means they have to be filtered out. They have to be removed before they enter into the combustion chamber, and that is where the requirement of the filter comes into picture. Now, what is this carburetor? So, as we discussed earlier, we require a device which is going to mix this particular air and fuel and prepare the mixture, because we are talking of petrol engines, SI engines. So, in SI engines, we are supplying air fuel mixture to the engine. That means we are preparing the mixture outside the engine. So before the engine, before this particular charge goes into the engine, it has to be in other words, the charge which is going to the engine should be air fuel mixture. It should not be air only, or it should not be the fuel only. Right? So we have to prepare the mixture as per requirement before the things are allowed to go into the combustion chamber, or before the fuel and air is allowed to go into the combustion chamber. We need to mix them in the proper conditions, in a proper manner, as per requirement, and then we will supply that particular mixture which has been produced as per the requirement, is then supplied to the engine combustion chamber or burning. Okay, and to prepare this particular mixture as per requirement, we have this particular device, what we call as a carburetor, and this particular mixture goes into the engine cylinder now, combustion chamber now. Okay, so this is the block diagram indicating the uh, fuel supply system for a petrol engine. So what are the components of a uh, petrol system, fuel system of a petrol engine or SI engine? It is the tank, it is the pump, there is a fuel filter, then we have a carburetor, and then the mixture is being produced and it is supplied to the engine. So moving ahead, now here it is shown uh, the same thing, fuel supply system, but in a different manner it has been shown. Earlier it was shown in a block diagram, the way the fuel to indicate the different components. Here we are saying showing their locations compared to each other. So here it is shown, air is coming in. Okay, air is filtered, and filtered air is going to carburetor. On the other side we have a tank, the fuel is being filtered, and the fuel is also going to carburetor. Okay, and this carburetor is preparing the air fuel mixture, and the mixture is going to engine. So now what is shown over here is a very important thing, that is air is being taken, air is going to be filtered. That means air filters are required. Similarly, fuel is taken and fuel is also filtered, and it is pumped. So in this particular line it will come the fuel filter and the fuel pump. Okay, so the filter and pump will come in this particular line. So earlier discussed, in the earlier slide we discussed, whatever we discussed was up to this. Okay, here we have now added this line also, that is the air line also. So we have a air coming in to the filter, so the filtered air is coming in, filtered fuel is coming in, and it is being mixed, and that particular device is what you call as a carburetor. So moving ahead now, here we will discuss some important things related to fuel supply system. So here we can read on this particular slide, we have written fuel passes through a number of stages before reaching the combustion chamber, which means we are preparing the air fuel mixture in the carburetor, and it is supplying to the engine, which we call as the fuel system. But in order to happen this, uh, it has to happen through different stages. So there are so many stages, okay, which need to be understood when we discuss about this particular fuel supply system in case of SI engines. Okay, so it is very important to understand the different stages, what these stages are, how these particular stages are working, what is the importance of each stage, and so on. Okay, so that understanding this particular part becomes a very important over here to understand the fuel system for CI engine, SI engine. Now, second thing it is written, it includes the filtration and atomization of the fuel into fine particles. So what it indicates? It indicates that the fuel need to be filtered uh, before it is being used. Not only filtered, it has to be atomized. So we know that the fuel is in the form of a flow. When it is flowing through the tank to the filter and so on. So we cannot use this particular flow of the fuel as it is. So what we have to do then? We have to convert this particular fuel flow into fuel droplets. So fine droplets we have to produce, and therefore it has to be filtered and atomized before it is going to be admitted to the combustion chamber. Then it is necessary to atomize the fuel. So atomization means breaking this particular flow into small particles. So that means vaporization has to take place, atomization has to take place, and vaporization also has to take place. There are different fuel systems for spark and compression diesel engines. That is for CI engines, and for SI engines we have different systems. Why we have different systems? Because the way in which we burn the fuel is going to be different, and accordingly we have different systems required for SI as well as CI. So now the air fuel ratio depends, the proper air fuel ratio is maintained with the help of a device known as carburetor. So in the earlier slides, one of the earlier slides, we have said that the air fuel ratio has to be maintained properly. That is when we said we require a mixture of proper quality and proper quantity. Okay, so that is where we are talking of air fuel ratio. Okay, here air fuel ratio means the quality of the mixture. So the air fuel ratio need to be maintained properly with the help of a carburetor. So carburetor helps in doing so, and it is then inducted to the combustion chamber. Then the air fuel ratio depends on various conditions. So it has to as per the requirement of different conditions. Means if the engine is starting, the mixture requirement is different. If the vehicle is overtaking another vehicle, then the mixture requirement is different. If the vehicle is accelerating, then the mixture requirement is different. If the vehicle is decelerating, the mixture requirement is different. If the vehicle is going up a hill, the vehicle mixture requirement is different. So for all the conditions, your systems should respond. Okay, then such conditions must be fulfilled before mixture enters the combustion chamber. So all these particular conditions, whatever we have discussed now, they have to be provisioned for coping up with these particular conditions before the mixture enters the combustion chamber. Then the fuel from the tank is delivered to the float chamber attached to the carburetor with the help of fuel pump. So this float, what is float chamber and all, we will discuss when we discuss the carburetor. The fuel pump maintains the constant pressure in the carburetor. So some level of the fuel has to be maintained properly. After this mixture of the fuel and the air is injected into the combustion chamber. So proper air fuel mixture is provided, and it is allowed to go into the combustion chamber. So this was something which we should know. Basically, what we understood in the previous slide was it has to go through different stages. What are these different stages? Fuel has to be taken from the tank, which is in the liquid form. Correct? It has to be made to flow to the region where we are going to prepare the mixture, which is carburetor. Correct? In the carburetor, it has to evaporate. And before evaporation to happen, we have to break up into small particles. So that means atomization. So atomization has to happen, evaporation has to happen. Okay, and when the evaporation is happening, we are converting the liquid fuel into vapor fuel. Okay, fuel vapor. And this particular fuel vapor is mixed with air. And then this particular mixture is being supplied to the engine. So these are the different stages to which it is going. Okay, and all those particular stages has to happen in such a manner that all the required conditions of the engine is going to be satisfied. Means whatever the mixture is going to be prepared, it should be as per requirement of quantity and quality which is required by the engine. So whenever the condition changes, for example, now the vehicle is going on a straight road. Suddenly now the vehicle has to climb the hill. So the condition changed. And according to the change in the condition, the mixture requirement has also changed. And the system should be able to respond to the change in condition. That means whatever the now the conditions required in terms of quality and quantity, it has to be able to cope up. Okay, so that is where we say the different stages it has to go before the fuel reaches into the combustion chamber for burning. Okay, now that is the same thing what we have discussed with the help of a diagram over here. So let us see what this diagram means. So the mixture requirement in a SI engine is being put on this particular slide. Under normal condition, it is desirable to run the engine on a maximum economy mixture. So when a normal running, that is, suppose the vehicle is moving on a highway. So what is our aim? The aim is to keep the moving vehicle in a proper moving condition. We don't want to accelerate. We don't want to decelerate. Continuously running at a particular speed. And under such conditions, we want economy. So our aim in such condition is economy, not the power. Okay, and we say here around 16:1 air fuel ratio is required. So 16:1 air fuel ratio is required. So it is shown here. Air fuel ratio is shown on this axis, and the power output is being produced by the engine is shown on this axis. So we are using 16:1 air fuel ratio. What is this 16:1? Again, we will be discussing about the air fuel ratios, etc. in detail. So basically, 16:1 air fuel ratio means in a 16 volume of air, 1 volume of fuel is being mixed. Okay. So for example, if I take liters, then if I use 16 liters of air, then I will use 1 liter of fuel. Okay, or 16 volume of fuel and 1 volume of air in volumetric terms. In mass terms, if I say say in mass terms, then I will say 16 for 16 kg of air, 1 kg of fuel. Okay, in mass terms. So that is where we have here this particular ratio coming into picture, which we call as air to fuel ratio. So 16 quantity of air, 16 units of air and 1 unit of fuel. This is what we call as 16:1 ratio, air fuel ratio. So generally 16:1 air fuel ratio is considered to be required for economic operation, while for quick acceleration, that is when the vehicle is trying to accelerate, that is when suppose I am trying to overtake another vehicle, at that time we want to accelerate. So when sudden acceleration is going to be there, our requirement is not now the economy, our requirement is now the power. So our requirement has been changed now, and according to the change in requirement, we want rich mixture. Here we required economy mixture, here we have rich mixture, which is around 12:1. So you can see over here we are getting, so this is a power output line, and we can see the maximum power output we are getting at 12:1 air fuel ratio. That means whenever our power is our requirement, then we have to use 12:1 air fuel ratio. But you can see this is the fuel consumption. Fuel consumption is going to be minimum at what? 16:1. So that we call it as economy. So the economy mixture is 16:1, while the power mixture is 12:1. That means if you want to have maximum power, then you should use 12:1 air fuel ratio. If you have economy, then you have to use 16:1. So that is the meaning coming out of this. So this is a consumption line, fuel consumption line. So here if a mixture is having a air fuel ratio of 10, 12, then the consumption is more. Similarly, if mixture becomes 18:1, then also the consumption is more. So the consumption is minimum for 16:1. Similarly, we have the power. So initially the power is lesser, but at 12:1 air fuel ratio, the power is maximum. Then as we go on changing the power air fuel ratio from 12 to 14, 16, 18, the power output is going to decrease. So this uh, preferably this you might have seen in the speedometer, where there will be one range, green range. Okay, and in that particular green range, this will be corresponding to the green range. So on a higher speed you go or on the lower speed you go, you will have the consumption to be more. That is why you will be preferred to run in the green range, which is shown in the speedometer. Okay, so preferably for a bike, etc., it will be around 50 to 70 or something in that particular range. Okay, if you, that means what it means is that if you run in the vehicle in that particular range, your consumption, fuel consumption, is going to be lesser. If you run the vehicle at a lesser speed than that, or higher speed than that particular range, that is beyond the green range, on the lower side or on the higher side, your fuel consumption is going to increase. Fuel consumption is increasing over here, fuel consumption is increasing over here, and this is the range where you are getting fuel consumption to be more economical, that is less, because the consumption is going to be minimum. Okay, so that is what is indicated by this, and which means that a 16:1 air fuel ratio is suitable for uh, economic running of the vehicle, while 12:1 fuel air ratio will be suitable for uh, power, higher power. Now, this again you can compare with the bike. Suppose if you are using a certain bike which has higher power, then they will be set for a air fuel ratio in this particular range. But if you use the bike like a Splendor, which is considered to be having high economy, then that will be set to this particular air fuel ratio. Okay, so that bikes which generally are more suitable for running at a high power, which are giving higher power, they will be set for this particular air fuel ratios. And those which are set for economic running, they will be set for this particular range. Okay, so that is what which we call as the mixture requirement for SIM. That means the requirement of the mixture is a variable parameter, and depending on what we want in a particular condition, the mixture requirement is going to change. So sometime we will be requiring a, power mixture, while during other time we will be requiring a economy mixture. Okay, that means suppose I am running on the highway now, and what I require to now do, I want to ensure that the moving bike is moving, or my vehicle is moving, and it has to move at the same speed whatever it is presently moving. At a speed is suppose 70, 60, whatever I have set. I don't want to accelerate more or decelerate. I'm not going to change the position of the accelerator. So just I want to continue running. So in this particular condition, my aim is to have economy. So we want economy mixture in this particular case, and at that time your requirement is 16:1. Okay, in this particular range. But suddenly a vehicle is coming in front of me, and I'm going behind some another vehicle. So suddenly I decided to overtake that vehicle. So if I want to overtake, I have to accelerate. Then suddenly, due to since acceleration is my requirement, that means power is my requirement. I want to shift from, I will be shifting from 16:1 to 12:1 fuel ratio, which is 12:1. I call it as a rich mixture, or it is a power mixture. Okay, maximum power mixture. So this is a best power range, while this is a best economy range. So that is what is indicated in this particular slide, what we call as the mixture requirement. So what you need to understand from this particular slide is that the mixture requirement is not a constant one for the engines. Okay, it is going to change from time to time, as the condition changes, the mixture requirement needs to be changed. Okay, sometimes the mixture requirement is leaner, so this side we call it as a leaner, and this side we call it as a richer. Okay, so what is this lean and what is rich, we will be again explaining in detail in coming slides. So basically, what you need to understand that sometimes it is a leaner requirement. So when we say it is leaner, we say more air, and we say when we say richer, it is more fuel. So either lean mixture will be required or rich mixture will be required as per the condition changes, and that has to be satisfied by your fuel system. Okay, so your fuel system, whatever you are going to design, see now you are thinking in terms of as a mechanical engineer, so you should always think is in terms of designing the system. So if you want to design a system for a SI engine, then you need to understand that your system is going to require sometimes a lean mixture and sometimes a rich mixture, and the device whatever you are going to use for preparation of this mixture is what you call as a carburetor, correct? And this particular carburetor should be able to comply with this particular requirement. Okay, so that is about this mixture requirement of the engine. Now, so whatever we have discussed now is basically the mixture requirement. Moving ahead, we will discuss about what you call as a carburation. Now, here, as we said, carburetor is a device which prepares the mixture, and the process of preparing the mixture is what you call as carburation. So, what is carburation? It is the process of formation of the combustible air-fuel mixture by mixing proper amount of fuel and air before it is introduced into the combustion chamber. So the air fuel mixture is being introduced into the combustion chamber, and this particular combustion chamber, air fuel mixture, before it is introduced into the combustion chamber, has to be ensured that a proper air fuel mixture has been formed, and this process of formation of proper air fuel mixture as per requirement, okay, this is what you call as carburation. So what is carburation? Carburation is the process of formation of mixture, air fuel mixture as per requirement before it is introduced into the combustion chamber. This is called as carburation. Now, what are the different parameters which are going to affect the carburation process? Because once you say carburation, you should also understand what are the parameters which are going to affect on carburation. So there are so many parameters which are going to affect. For example, engine speed. Correct. So how engine speed is going to affect? So we know that when the engine speed increases, the number of cycles of operation are going to increase. That means if I say I take a two-stroke engine, then I will say that if the engine is running at 1000 RPM, then there are 1000 cycles happening. Okay, 1000 cycles happening. If it is a four-stroke engine, then I will say there are 500 cycles happening, because we know that in a four-stroke engine we require 2 revolutions to complete 1 cycle. Okay, so now for completing each cycle, we require some amount of time, correct? And as the engine speed increasing, what is the meaning of that? Now we say the engine speed has increased from 1000 RPM to 2000 RPM. And what is this RPM? Rotations per minute or revolutions per minute. That is time remains the same, minute, but in 1 minute now your engine is going to rotate or revolve. Its crankshaft is going to revolve 2000 times instead of 1000 times. That means your time available for completing the operation has been decreased because the engine speed has been increased. So that is where how it is going to affect the operation process, because now we have lesser time to complete the same things whatever we are doing earlier. At 1000 RPM, whatever we were doing, we were having some amount of time, and the same thing has to be done now with a lesser time. That is how the time is going to, engine speed is going to affect. Uh, the second thing what is going to affect the carburation process is the vaporization characteristics of the fuel. So what is this vaporization characteristics? So that means here how much easily the fuel can be vaporized. This vaporization characteristics. Correct. So if a fuel is able to easily convert into vapor, obviously we can prepare the mixture faster and we can supply. But if that particular fuel is unable to convert into vapor easily, that is, it has poor vaporization characteristics, then we will not be able to complete the vaporization process in the available time, and the fuel which is going to the combustion chamber will not be complete vapor, but it will be going in the form of liquid droplets. And we know that once our liquid droplets are going in the combustion chamber, they may burn or may not burn, we cannot ensure. Because we have designed the system for burning the air fuel vapor mixture. I repeat again, we have designed the system for burning the air fuel vapor mixture, air plus vapor of fuel vapor mixture. We are not saying air fuel liquid in the liquid form, no, we are talking of air fuel vapor mixture. So we are considering that, we are assuming that all the fuel, liquid fuel is being converted into vapor before it is being supplied to the combustion chamber. Because we said during carburation process. So when we define the carburation process, what we said, carburation is a process in during which it is a formation of combustible mixture, burnable mixture, combustible mixture, which can be burned, mixture which can be burned. And which mixture can be burned properly, which is in the form of air fuel vapor mixture. Okay, so that is where we say we have the carburation process, and the carburation process is going to be affected by the vaporization characteristics of the fuel also. Okay, so the speed was affecting, vaporization characteristics are going to be affected, then also temperature may be also affecting, because temperature of the air, because we are mixing the fuel with the vapor, sorry, with the fuel, correct, air with the fuel. Now when we are going to mix this particular fuel and air, the temperature at which we are taking the air is going to also going to take a have a considerable effect, because where the fuel is going to get the heat for vaporization, it is from the air. And if the air is allowed to go at a higher temperature inside the engine into the carburetor, it means more heat is available for vaporization. If the cold air is we are going to supply to the carburetor, it means less heat is available for vaporization. But we know that vaporization process has to happen. It means the carburation process is also going to be affected by the incoming air temperature. Similarly, pressure also. So the atmospheric conditions are going to affect, atmospheric air conditions are going to affect, ambient conditions are going to affect the carburation process. And obviously, how we have designed the carburetor. So because this particular process of formation of mixture, combustible mixture, is happening inside the carburetor, and how we have designed the carburetor is also going to affect. So these many parameters we need to keep in mind when we are thinking of a carburation process. So we said carburation process is a process of preparing the combustible mixture as per requirement of the engine before it is being supplied to the combustion chamber. Okay, so and we say the different parameters which affect the carburation process are the engine speed. So speed may affect, then vaporization characteristics are going to affect, the temperature of the temperature and pressure of the air, and air which is being inhaled by the carburetor for supplying it to the engine is going to be affect, and the design of the carburetor is also. So this is about the carburation process. Okay, and as we have discussed in the previous slides, we have to go all this particular thing in different stages. Okay, and we can say the different stages as the first stages is we have to take the mixture in order to prepare the mixture, we have to take the liquid from one side. So here in this particular slide, we have said uh, here we have said we are taking the fuel from this side. Correct. So now how much fuel we have to take? How much fuel we have to take? That means we have to ensure that a fixed quantity, measured quantity of fuel has to be supplied. So there should be some provision of measuring the fuel should be here, because we are going to take some amount of liquid we are allowing to come into the carburetor. Okay. Similarly, this particular fuel which is coming in, whatever the quantity we are going to take in, suck in, is going to be atomized properly. That is, it is broken up into smaller particles. Now, why we are making it to break up into smaller particles? So, if you have ever gone into what you call as a we have the small regions where we that is we have a closed region where we generally prepare the small saplings of a small plants. Okay, which we call as what we call as them as uh, we call them as basically. Can anybody tell me if everybody is hearing? जिथं आपण छोटे छोटे झाडांचे रोप तयार करतो, व्हॉट वी कॉल इन दॅट पर्टिक्युलर रिजन, कुठे तयार करतो आपण?
नर्सरी. नर्सरी.
नर्सरी. ओके. आणि तिथं जी कंटे वी हॅव अ शेड लाईक अ रिजन, एनक्लोज रिजन, त्याला काय म्हणतो आपण?
शेड नेट.
शेड नेट. Okay. So in that particular region, preferably when you go inside that, you might have observed that the atmosphere is maintained cold with the help of spraying the water. Have you observed?
Yes.
Yes. So what it means is that here, what is happening over there, due to which that particular atmosphere is maintained at a lower temperature. So what we do is we spray the water in a droplet form. Now, what is happening when the droplet is going over there? Every droplet is now surrounded by air, and therefore every droplet is able to take some amount of heat from the air which is surrounded by that particular droplet. So now we have increased the surface area of water by breaking up into smaller particles. Okay, why we have done this? Because we want to absorb the heat. Now, when we absorb the heat, that particular surrounding region becomes cooler in this particular shed net, whatever you are talking of. Similarly, in a carburetor, when we supply this particular fuel, we break up into smaller particles. Why? We want to ensure that the heat is taken from the air by the fuel, and the fuel is going to get converted into vapor. How it is getting converted into vapor? By absorbing the heat. And where the heat is available? Heat is available in the air. So we have to prepare a condition such that it is able to absorb more amount of heat. So what is that condition? We have atomized it. So by atomizing, what we are able to achieve, we are able to increase the surface contact area of the fuel and the air. Why we have increased the surface contact area? Because we want to absorb more amount of heat. Why we want to absorb more amount of heat? Because we want to convert the fuel into vapor. More the heat it is able to absorb, more amount of fuel will be able to convert into vapor. So whatever amount of fuel we are going to supply to the carburetor, it has to be atomized. And this particular atoms or droplets of proper size. So the first step we said, we have to measure the fuel, and then we have to atomize it properly. Okay, so this atomization into a droplet of a proper size is very important, because if the droplet size is bigger, maybe that all the fuel will not be able to convert into vapor. If the droplet size is going to change, then something else might also happen. So all this, so proper size of the droplet is very important. Okay, so measuring the fuel and then automation of the fuel, then we have to take the air from here and then mixing has to be done over here. So why? Because we have to ensure that the fuel is going to be distributed in the air in a uniform manner. So uniform mixing of the fuel particles in the air is very important, which has to happen over here, so that we can prepare a mixture of uniform strength. It should not happen that if you take a mixture from one corner, it is having different amount of fuel, and if you take some sample from the different corner of the region, we are going to have different amount of fuel with respect to air. So we want a uniformity of fuel and air throughout the mixture. And for that, some mixing has to be done over here. So after mixing, then we will be supplying it to the engine. So the different stages, generally, when we talk of different stages, we generally terms like we have some proper measuring mechanism for fuel as well as air, because we want to ensure that air fuel ratio requirement. Okay, so when we are talking of air fuel ratio requirement, means we are measuring the fuel, we are measuring the air, we are bringing it in this particular region what we call as a carburetor. Okay, now the problem arises here is that here we have the air which is a gaseous. Okay, this is a gas, while the fuel is in the form of liquid. Now the problem arises is that we cannot mix a gas with a liquid. We can mix a gas with a gas or a liquid with a liquid, correct? And therefore, before mixing, then two options are there. What is that? Either air has to be converted into liquid and then liquid can be mixed in the fuel, liquid fuel, or the liquid has to be converted into gaseous form and then we can mix it with the air. So that is where the requirement of atomization and vaporization comes into picture. Okay, so because converting the air into liquid is very difficult, and in this particular region we can say it is not a feasible solution, and therefore what we prefer to do, we prefer to convert the liquid fuel into vapor, fuel vapor. That is where we say we have to supply air fuel vapor mixture to the engine. Okay, so remember, the fuel has to be in the vapor form, not in the liquid form. Okay, that is very important, and therefore we take a fixed quantity of air, we take a fixed quantity of fuel, we atomize the fuel, and atomization has to be into fine proper size particles. Now, how much particles proper size? So that all the fuel, liquid fuel, is able to convert it into vapor. And there should be some provision to mix. And why the mixing has to be there? In order to ensure that a uniform mixture is being produced. And that uniform mixture is being supplied to the engine. So here this thing happens. So in the first stage, we require to measure the air as well as liquid which is coming in, or the fuel which is coming in. Okay, then we have to break the liquid fuel into small particles, which we call as atomization. Then we have to mix this particular after atomization we have what we call as a vaporization of the fuel. Once it is vaporized, that means now we have air and fuel vapor. Then now we are going to mix it properly to form a uniform air fuel vapor mixture, and that need to be supplied to the engine. Okay, so all these things happen here in this particular system, what we call as a fuel supply system for a SI engine. So here metering the fuel and air means measuring. Metering means measuring. So metering the air and fuel, atomization of the fuel, evaporation of the fuel, mixing of the fuel vapor with the air, and then supplying it to the combustion chamber. All these things happen in this particular system, what we call as fuel supply system for SI engine. So it is 11:53. Now I think To some extent, I have covered what is carburation process, what is the requirement of a mixture, and the requirements of a fuel for IC engine. So I started with the requirement of the fuel for engines, and then I moved on to the requirement of the SI engine fuel supply system. I discussed what are the different components of the fuel system, and uh, later on I discussed what are the requirements of the mixture. Okay, mixture requirements, and the carburation process, and the factors affecting the carburation process, and the stages of carburation process we discussed. Any doubt in this, you can ask. Session open for questions. I expect everybody to ask the question, so that I have a feel that you are able to understand what has been discussed over in the class. So some questions before marking the attendance and leaving. Nobody should leave now.
सर
Please.
पेट्रोल कार्बोरेटर मधून सिलेंडर मध्ये जाताना वेपर फॉर्म मध्ये जातं का ड्रॉपलेट फॉर्म मध्ये जातं?
ड्रॉपलेट आपण त्याला पहिल्यांदा ॲटोमायझेशन करतोय म्हणजे ड्रॉपलेट होते, आणि ते प्रत्येक ड्रॉपलेट एअर मधून हीट ऍब्सॉर्ब करते. कशासाठी? वेपराइज होण्यासाठी. एक्सपेक्टेड काय आहे? एअर प्लस वेपर मिक्सचर, फ्युएल वेपर मिक्सचर, हे एक्सपेक्टेड आहे. So as per the requirement, we say what is required to go into the combustion chamber is air fuel vapor mixture, not air fuel liquid mixture. No, requirement I am talking of requirement. But in actual maybe that under some conditions some liquid may go, fuel may go in the liquid form, fuel droplet form, because the carburation process may not be happening 100% always perfectly in carburetor. Okay, but theoretically saying, we want air fuel vapor mixture going into the engine. I hope PC I have cleared it.
Yes sir.
Okay. Any doubt? Other doubt? Very good question from PC. Yes, any other question? Okay, if you don't have any questions, please mark your attendance, and you may leave now. So mark your attendance in the chat box. Remember, I am also having a attendance sheet over, different attendance sheet over here. I will be verifying it, but ensure that everybody, because if you are not putting your attendance in the chat box, I will not mark your attendance, which I was doing early, but now I will not do it. So ensure that you are putting your attendance in the chat box before leaving. And you may leave now, because after 12 you have to go for